Yeah, good afternoon, everyone. Welcome to Mentor Smart Tutor. Today we'll be talking about solubility / hydrolysis of salts in water. But first and foremost, you need to understand that not all salts are soluble in water. I will start from the nitrate. All nitrate salts are soluble in water. Then the chloride, all chloride salts too are soluble in water, except that of silver chloride. While for the sulfates, all sulfate salts, for example, copper sulfate, are all soluble in water, except that one of barium and calcium sulfate. And for the carbonate, you need to know that all carbonates are insoluble in water, except the salts made from sodium ion, potassium ion, and ammonium ion. Those are the only ones that are soluble in carbonate salt. Now, when you now add them to water and the thing becomes soluble, what happens to the solution? Will the solution become acidic, basic, or neutral? In order to verify that, we will need to do some little tests of this particular salt. Now, the one I'm holding here is ammonium sulfate. I will take the little ammonium sulfate. Take the little ammonium sulfate. This is how ammonium sulfate is. Take the little ammonium sulfate. Put it in a test tube, which I'm doing already. Put it in a test tube. Then I will add little distilled water to it in order to see if it is going to be soluble or not. Then I shake. Now when I shake, I will expect the solution to become soluble, because I've already told you that all sulfate salts are soluble in water except the one made from barium or calcium ions. Now the thing has already dissolved in water. Then I need to test it inside. I need to test it with litmus paper. This red litmus paper. Let's see what happened. Wow, it is neutral in this litmus paper. They won't confirm yet. I have to use blue litmus paper as well. This blue litmus paper, and see what is going to turn to. Oh, wow! You could see a little red color or a little red coloration coming out from the solution. This particular thing is showing that this solution is acidic. Then the question is, why is the solution acidic? Fine. When you look at the bulb, this is the salt, which is solid. I dissolve it in water to form a aqueous solution. Then it will split into ammonium ion and sulfate ion. Then the water itself will split into hydrogen plus and the OH minus. As we all know that light charges attract, then there's going to be a reaction between this and this to form H2SO4 inside the solution. And there's going to be a reaction between ammonium ion and the hydrogen ion to form ammonium hydroxide. This is a weak, this is a strong acid, H2SO4, as we know, and this is a weak base. And what happens to the equilibrium? Equilibrium will shift towards the strong acid, making the solution to be acidic, as we've already demonstrated before. And that's what happened in ammonium sulfate. Another one I'm going to talk about is sodium carbonate. I've already told you that when you have sodium carbonate, all carbonate salts are insoluble except the one made from sodium, potassium, or ammonium sulfate. Therefore, to demonstrate this, I will take this is how sodium carbonate look like. What I'll do is I will take few of the solution, few of the salt, put it in a test tube. When I put it in a test tube, get my distilled water to form a solution. I'm forming solution already. Then, when I get the solution, then I have to shake in order to confirm it with the soluble or insoluble. Yes, in this particular case, okay, it's dissolving. But the rate at which the thing is dissolving is very slow, and it has a gas inside, which we need to be more careful when you are trying to dissolve the salt, so that you don't build up pressure that can pull out your hand from the cover. Okay, I think I have some level of solubility of the salt in water. Then I need to test if the solution is acidic or basic. Now, in order to do that, I will need to add, well, I use red litmus paper and the thing turns to blue. Likewise, I have to consider blue litmus paper and see what will happen. Instead, if you use a blue litmus paper, you are going to have it neutral because the solution itself is basic. Therefore, when I have this, see, it has no effect on blue litmus paper. Meanwhile, the one I did before, it turned red to blue, telling me that the solution is basic. Now, why is the solution basic? That is the chemistry aspect of it which you need to understand. Now, when you come to the board, this sodium carbonate solid, putting it in water to form a solution, is split into sodium ion and carbonate ion. Then the water itself will split into hydrogen plus and OH minus. Now, what happens? The unlike charges attract. The sodium plus will combine with OH minus to form sodium hydroxide, which is a strong base. Meanwhile, the hydrogen plus will combine with the carbonate to form a weak acid. Now, what happens to the equilibrium? The equilibrium will shift towards the strong base to form what we call a basic solution. And that is what we've already demonstrated. If we try it again, if I put red, to see now I have a total solubility of the salt in water. If I put it again, now you can see that the thing is turning blue, telling me that this particular solution I'm seeing is a basic solution. Good. That's another one. Then the last one that I'm going to talk about, although we have other salts that we can equally show if they are soluble or not, is sodium chloride. The sodium chloride, we have the table salts, the one we use at home, but this is an industrial sodium chloride that we use in the lab. Now, this one is made up of sodium and chlorine. We have to see if it is soluble or not. And I've already told you that all the chloride salts are soluble in water, except that of silver chloride. All I needed to do is take few of this particular solution, take small of this particular solution, put it inside the test tube. Then when I do that, what happens is, solid, they have to add water to make it the solution. Then I pour the water. When I pour the water, I have to shake. Then when you are shaking, you have to be very careful so that the test tube will build up gas, because in case when you have gas, you push up your hand on the cover. Okay, you see now that the salt is soluble in water. Therefore, what I need to do, I need to test the solubility of this particular salt. I can still use it. This is blue. Let's see what will happen to the blue solution. See, it's neutral to the blue solution. Then let me get a red and see what will happen to the red litmus paper. Wow. See, it's equally neutral to the red litmus paper. Now, what is the implication of this particular thing? The chemistry in it is very simple. When you have the sodium chloride in water, let me put aqueous here. In water, it will split into sodium plus and chloride ion. Meanwhile, this one will split into hydrogen plus, this one will split into hydrogen plus and OH minus, all inside the solution. Then, unlike charges, we attract each other. Why? The sodium plus will come to OH minus and combine to form sodium hydroxide. And the sodium hydroxide happens to be a very strong base. Meanwhile, the Cl minus will combine with hydrogen plus to form a HCl, which that is a very strong hydrochloric acid. And what happened? We have a strong acid, we have a strong base. What happened to the equilibrium position? The equilibrium position becomes balanced, meaning that it cannot go to the acid side, it cannot go to the base side. Then we now stay at the middle, making the solution to be neutral to litmus paper. I hope you've enjoyed the little demonstration about the salt hydrolysis. If you have any questions, you can tag us and ask questions. Thank you for listening.